ನಮಸ್ಕಾರ. ಜ್ಞಾನತರಂಗ ನೀಟ್ ಆ್ಯಂಡ್ CET ಕೋಚಿಂಗ್ ಕ್ಲಾಸಸ್ಗೆ ಮೆಡಿಕಲ್ ಆ್ಯಂಡ್ ಎಂಟ್ರೆನ್ಸ್ ಇಂಜಿನಿಯರಿಂಗ್ ಎಂಟ್ರೆನ್ಸ್ ಎಕ್ಸಾಮ್ 2018-19ಗೆ ವಿದ್ಯಾರ್ಥಿಗಳನ್ನು ಸ್ವಾಗತಿಸ್ತಾ ಇದ್ದೇವೆ. ಇದು ಕರ್ನಾಟಕ ಸರ್ಕಾರ ಮತ್ತು ಪದವಿ ಪೂರ್ವ ಶಿಕ್ಷಣ ಇಲಾಖೆಯಿಂದ ನಡೆಯುತ್ತಿರೋ ಕಾರ್ಯಕ್ರಮ. ನಾನು ಎ ಶ್ರೀಧರ್ ಪ್ರಸಾದ್, chemistry lecturer. I am discussing about the P block elements, which includes 16, 17, 18 group elements. Regarding synopsis, group 16 elements, that is oxygen family. This group includes oxygen, sulfur, selenium, tellurium, polonium. Among these elements, polonium is a radioactive in nature. The valence shell electronic configuration of these group elements is NS2, NPX2, NPY1, NPZ1. Regarding oxidation states, oxygen shows only -2 valency, but in case of oxygen difluoride, it shows +2. Other elements like sulfur, selenium, tellurium, polonium shows +2, +4 and +6 due to presence of vacant d orbitals. Except in polonium, it does not show +6 valency because due to inert pair effect. As the atomic number increases down the group, atomic or ionic radii increases, ionization enthalpy decreases, electronegativity, that is attracting electron pair, decreases, metallic character increases. In this family, oxygen shows abnormal properties from the other elements, that is due to smaller atomic size, high electronegativity, absence of d orbitals. The dihalides have angular geometry, tetrahedrals have seesaw geometry or pyramidal geometry, hexahalides have octahedral geometry. The formula of Marshall's acid is H2S2O8. It is also called as per disulfuric acid. The formula of Caro's acid is H2SO5, which is sulfurous acid. Regarding molecule and geometry, SO2 is V-shaped, called angular, H2SO3 pyramidal shape, H2SO4 tetrahedral shape. Synopsis regarding group 17 elements, that is halogen family. This group includes fluorine, chlorine, bromine, iodine, astatine. Valence shell electronic configuration is NS2, NP6, NPX2, NPY2, NPZ1. Oxidation states. All elements show minus oxidation state, -1 oxidation state. But other elements except fluorine shows +1, +3 and +5 and +7 due to presence of vacant d orbitals. As the atomic number increases down the group, atomic or ionic radii increases. Ionization enthalpy, that is removing one electron from isolated gaseous atom, also decreases. They have high electronegativity in nature. Because they are nearest to inert gas configuration, they easily attract the electron, hence high electronegativity in nature. The electron gain enthalpy decreases down the group. Reason is, as the atomic size increases, the attraction between the electron as well as the nucleus decreases, hence electron gain enthalpy also decreases down the group. Note, chlorine has high electron gain enthalpy than fluorine because of Fluorine has small atomic size and large electron density, that is interelectronic repulsion. Fluorine has less electron gain enthalpy than chlorine. Fluorine shows abnormal properties from other elements due to smaller atomic size, high electronegativity, absence of d orbitals, low fluorine-fluorine bond dissociation energy. Halogens reaction with hydrogens. They form hydrogen acids. The reactivity decreases down the group, but acidic strength increases down the group. Interhalogen compounds. Halogens themselves combine to form interhalogen compounds like AB, AB3, AB5, AB7, in which A is larger size halogen and B is smaller size halogen. Geometry of the interhalogen compounds. If AB type halogen, hybridization is sp3, geometry is linear. In case of AB3, sp3d hybridization T-shaped. In case of AB5, sp3d2 hybridization square pyramidal. In case of AB7, sp3d3 hybridization pentagonal bipyramidal. Next comes to the group 18 elements. Those are called inert gases. This group includes helium, neon, argon, krypton, xenon and radon. Valence shell electronic configuration. These elements will have completely filled electrons like Ns2, Npx2, Npy2, Npz2. In this group, all the elements are gases and except radon occur free in atmosphere. Radon is obtained during alpha decay of radium. Regarding properties, as the atomic number increases, atomic or ionic radii increases down the group, that is atomic size increases. They have high ionization enthalpy, decreases down the group. To remove electron, it needs high ionization energy. They have no electron gain enthalpy. In this group elements, they do not show any interest to attract electron pair, hence they do not have electron gain enthalpy. Among the elements, xenon forms large number of compounds with oxygen and fluorine, that is oxides, fluorides and oxyfluorides, in which oxidation state of xenon is +2, +4, +6 and +8 also. Next, we will discuss some of the multiple choice questions regarding these chapters. That is 16th group. Oxygen differs from their other elements from its family members. Options are small atomic size, its high electronegativity, absence of d orbitals, all these. ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಆಕ್ಸಿಜನ್ ಈ ಫ್ಯಾಮಿಲಿಗೆ ದಲ್ಲಿ ಎಲ್ಲ ಪ್ರಾಪರ್ಟೀಸಕ್ಕೂ, ಎಲ್ಲ ಎಲಿಮೆಂಟ್ ಪ್ರಾಪರ್ಟೀಸಕ್ಕೂ ವ್ಯತ್ಯಾಸ ಇರುತ್ತೆ. ರೀಸನು ಸ್ಮಾಲ್ ಅಟಾಮಿಕ್ ಸೈಜ್ ಇರೋದ್ರಿಂದ, ಹೈ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ, ಆಬ್ಸೆನ್ಸ್ ಆಫ್ ಡಿ ಆರ್ಬಿಟಾಲ್ಸ್, ಆಲ್ ದೀಸ್. ಇದಕ್ಕೆ ಸೂಕ್ತವಾದ ಆನ್ಸರ್ ಬಂದು ಆಲ್ ದೀಸ್. ಆಕ್ಸಿಜನ್ ಸಣ್ಣ ಎಲಿಮೆಂಟ್ ಆ ಗ್ರೂಪ್ ಅಲ್ಲಿ, ಹೈ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವಿಟಿ, ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಬಹಳ ಈಸಿಯಾಗಿ ಅಟ್ರಾಕ್ಟ್ ಮಾಡೋ ಕೆಪಾಸಿಟಿ ಇರುತ್ತೆ. ಆಬ್ಸೆನ್ಸ್ ಆಫ್ ಡಿ ಆರ್ಬಿಟಾಲ್ಸ್, ಡಿ ಆರ್ಬಿಟಾಲ್ಸ್ ಇಲ್ಲ ಅದರಲ್ಲಿ. ಸೊ ಎಲ್ಲವೂ ಸೂಕ್ತವಾಗಿರೋದ್ರಿಂದ ಆನ್ಸರ್ ಬಂದು ಡಿ, ಆಲ್ ದೀಸ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. ದ ರೇಡಿಯೋ ಆಕ್ಟಿವ್ ಎಲಿಮೆಂಟ್ ಬಿಲಾಂಗಿಂಗ್ ಟು ಗ್ರೂಪ್ 16. ಗ್ರೂಪ್ 16 ದಲ್ಲಿ ರೇಡಿಯೋ ಆಕ್ಟಿವ್ ಇರೋ ಪ್ರಾಪರ್ಟಿ ಎಲಿಮೆಂಟ್ ಯಾವುದು? ಟೆಲೂರಿಯಂ, ಪೊಲೋನಿಯಂ, ಸೆಲೀನಿಯಂ, ರೇಡಿಯಂ. ರೇಡಿಯಂ 16th ಗ್ರೂಪ್ ಅಲ್ಲಿ ರೇಡಿಯೋ ಆಕ್ಟಿವ್ ಎಲಿಮೆಂಟ್ ಪ್ರಾಪರ್ಟಿ ಇರೋದು ಪೊಲೋನಿಯಂಗೆ ಮಾತ್ರ ಇರುತ್ತೆ. ಸೊ ಆನ್ಸರ್ ಈಸ್ ಬಿ. ನೆಕ್ಸ್ಟ್, ಅಮಾಂಗ್ ಗ್ರೂಪ್ 16 ಎಲಿಮೆಂಟ್ಸ್ +6 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಈಸ್ ಪಾಸಿಬಲ್ ವಿತ್. ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ +6 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅನ್ನ ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ? ಸಲ್ಫರ್ ಅಂಡ್ ಸೆಲೀನಿಯಂ ಎರಡೂ ಮಾಡ್ತಾವ. ಸಲ್ಫರು, ಟೆಲೂನಿಯಂ ಇವು ಎರಡೂ ಮಾಡ್ತಾವ. ಸೆಲೀನಿಯಮು, ಟೆಲ್ಲೂರಿಯಮು ಇವು ಎರಡೂ ಮಾಡ್ತಾವ. ಸಲ್ಫರು, ಸೆಲೀನಿಯಮು ಅಂಡ್ ಟೆಲ್ಲೂರಿಯಂ ಈ ಮೂರನ್ನೂ ಮಾಡ್ತಾವ. ಸೊ ಆನ್ಸರ್ ಈಸ್ ಡಿ, ಸಲ್ಫರ್, ಸೆಲೀನಿಯಂ ಅಂಡ್ ಟೆಲ್ಲೂರಿಯಂ. Next question. The geometry of tetrahedral halides of group 16 elements is, as per synopsis, they show the geometry of tetrahalides of group 16 element is metal with 4 halogens. It is pyramidal structure, or it is also called as seesaw structure. So answer is pyramidal structure as per synopsis. Next, which would quickly absorb oxygen? Options are alkaline solution of pyrogalol, concentrated sulphuric acid, lime water, alkaline solution of copper sulfate. Among these, as you know, concentrated sulphuric acid absorbs water, lime water absorbs carbon dioxide, alkaline solution of copper sulfate absorbs water. So the suitable answer is alkaline solution of pyrogalol. The pyrogalol structure is 1,2,3 trihydroxybenzene. 1,2,3 trihydroxybenzene is called pyrogalol, which absorbs oxygen quickly. So suitable answer is A. Next question. Among the following, the amphoteric oxides are. Amphoteric oxides mean they act as both acids as well as bases. Among the options, A, zinc oxide, B, sulfur dioxide, C, both of these, D, none of these. Sulfur dioxide is a gas which acts as only acidic property, whereas zinc oxide acts as both acidic as well as basic nature. Hence, this acts as an amphoteric oxide. Answer is A. Next, by passing H2S gas in acidified KMnO4 solution, we get acidified KMnO4, KMnO4 plus H2SO4 plus H2S. It forms potassium sulfate plus manganese sulfate, water and yellow precipitate of sulfur, where acidified potassium permanganate oxidizes H2S to yellow precipitate of sulfur. So, among the options, A is sulfur, B is potassium sulfide, C is manganese dioxide, D is potassium sulfite. So, the suitable answer is sulfur, A. Sulfur dioxide behaves as an oxidizing agent, reducing agent, both of these, none of these. Sulfur dioxide SO2, it acts as both oxidizing agents as well as reducing agents. Hence, the suitable answer is C. That is, it produces nascent oxygen atom as oxidizing agent and it produces nascent hydrogen atoms as a reducing agent during the reactions. So, suitable answer is C. Next question. The compound which gives off oxygen on moderate heating, means at low temperature the following oxides produces oxygen: cupric oxides, mercuric oxide, zinc oxide, aluminium oxide. As per Haligen diagram, mercuric oxide curve passes the delta GG0 curve at low temperature, hence it readily produces oxygen at very low temperature. That is, suitable answer is mercuric oxide, whereas cupric oxide, zinc oxide, aluminium oxide needs reducing agents to separate the oxygen from those metal oxides. At very low temperature, mercuric oxide produces oxygen as per Haligen's diagram. Next, the molecular geometry of sulphuric acid is pyramidal, square planar, tetrahedral, trigonal, bipyramidal. So, answer is tetrahedral. That is, this sulphuric acid produces two hydrogen atoms, hence it is a dibasic acid. It has the structure tetrahedral structure. So, suitable answer is C. Which of the following is not oxidized by ozone? Options are potassium iodide, ferrous sulfate, potassium permanganate, potassium manganate. Among the options, in case of potassium permanganate, manganese oxidation state is +7. Hence, it is not oxidized by ozone. Whereas ozone reacts with potassium iodide, ferrous sulfate as well as potassium manganate. But potassium permanganate, due to higher oxidation state of the manganese, it cannot be oxidized by ozone. So, the suitable answer is C. Oleum, it is an oil-like liquid. Its formula is H2S2O8. H2SO5, H2S2O7, H2S2O3. As you studied in manufacturing of sulfuric acid by contact process, sulfur trioxide gas absorbed in 98% of sulfuric acid to form oil-like liquid called oleum, that is SO3 plus H2SO4 gives rise to H2S2O7 called oleum. So, the oleum formula is H2S2O7. So, the suitable answer is C. Next, ClOH is called hypochlorous acid. Hypochlorous acid. Its structure is, it indicates whether it is an oxide. Options are oxide, chloride, an acid and hydride. The hydrogen atom is attached to oxygen atom and it is removable. Hence, as per the theory, it acts as an acid. It donates a proton. Hence, the name is also called as hypochlorous acid. So, answer is C. Among the following, the highest boiling point is of H2TE, H2S, H2SE, H2O. In case of H2O, due to high dipole moment between oxygen and hydrogen and high electronegativity comparatively all the remaining elements like sulfur, tellurium, selenium, water has maximum highest boiling point 100 degrees centigrade at 1 atmosphere. So, the answer is D. Next, the acid which cannot be stored in glass bottles. Students, as we observed in the regular classes, that is in the laboratories, HCl, HBr, HI which are stored in the bottles, HF, hydrofluoric acid, which cannot be stored in glass bottles because due to formation of fluorosilicic acid, HF reacts with silicon dioxide, that is glass, forming H2 SiF6 called fluorosilicic acid. So, answer is HF. Next, the strongest acid among the following is, suitable answers are, options are HClO2, chlorous acid, HClO4, perchloric acid, HClO, hypochlorous acid, HClO3, HCl, HClO3 called chloric acid. Among all the four, the chlorine oxidation state is maximum in HClO4. As you know, calculation of oxidation state is hydrogen plus 1, oxygen minus 2 into 2 minus 4. So left out is chlorine is plus 3 in the chlorous acid. In case of HClO4, minus 2 into 4 minus 8, hydrogen is H plus 1, chlorine is plus 7. Hydrogen oxidation state is plus 1, oxygen oxidation state is minus 2, chlorine is plus 1. In case of chloric acid, minus 6 is oxidation state of oxygen, hydrogen is plus 1, chlorine is plus 5. When we observe all the acids, in case of perchloric acid, chlorine oxidation state is plus 7, hence it is strongest acid. So suitable answer is B. Next, chlorine upon reaction with NaOH in cold, it produces, chlorine reacts with sodium hydroxide, which is a dilute and cold. It forms sodium chloride and sodium hypochlorite and water. So the obtained products according to this one is NaCl, NaClO, that is sodium hypochlorite, and water. The suitable answer is A. Next, HCl is covalent in nature, ionic in nature, covalent in nature in gaseous state, but ionic in water. Ionic in nature in gaseous state, but covalent in water. Students, ತಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ ಹಾಗೆ HCl, if it is in the gaseous state, it is called as hydrogen chloride. When dissolved in the water, the same HCl gas when dissolved in the water, we call it as hydrochloric acid. This indicates HCl in gaseous state covalent in nature, and when dissolved in the water, it is ionic in nature. As you know, HCl splits into, when dissolved in the water, as per Arrhenius theory, it splits into H plus Cl minus. This reaction indicates HCl is in water, it is ionic in nature. In gaseous state, it is covalent in nature. So the suitable answer is C. Formula of tear gas. The tear gas formula is chloropicrin. Its formula is CCl3NO2. These gas, when approaches to the ice, it produces tears and ice will become red. So hence it is called tear gas. Its formula is CCl3NO2 called chloropicrin. It is the commercial name of the tear gas. So answer is B. As you know, COCl2, carbonyl chloride, highly poisonous gas. N2O, nitrous oxide gas. In the interhalogen AB3, the state of hybridization of A is, as per the synopsis, the answer is sp3d. AB3, sp3d is the hybridization. So answer is B. In which of the following has maximum bond energy? Here options are chlorine, fluorine, bromine, iodine. Bond energy means to break the energy required to break the bond between two atoms. As per the halogen family, fluorine is highly electronegative element, hence it needs high bond energy. This bond energy decreases down the group. So fluorine has highest bond energy among the options. So suitable answer is B. But due to presence of interelectronic repulsion and smaller in size, chlorine has highest bond energy than fluorine. As already we have discussed this one in synopsis. Next, a radioactive element which resembles iodine in properties is lead, does not belongs to this family, astatine belongs to this family, radium does not belongs to this family, thorium also does not belongs to this family. Iodine is resemblance in with respect to astatine. So answer is B. Fluorine exhibits the oxidation state of -1 only because it readily accepts electrons, it is very strongly electronegative, it is a non-metal, it belongs to halogen family. As per the options, all were correct, but among those options, the appropriate suitable answer is to exhibit -1 valency. B answer, it is a very strongly electronegative which attract the electron pair, hence it exhibits -1 valency, that is oxidation state. The halogen which shows metallic character is chlorine, iodine, bromine, none of these. In the halogen family, metallic character increases down the group. Fluorine and chlorine are gases, bromine is a liquid, iodine is a solid which exhibits metallic character. Hence, among the following options, B is the suitable answer, iodine. Next, which of the following is not a chalcogens? Oxygen family generally called chalcogens. Oxygen family contains oxygen, sulfur, selenium, tellurium, polonium. Among this one, sulfur belongs to oxygen family, selenium belongs to oxygen family, oxygen is also belongs to same family, sodium belongs to first group of the periodic table called S block elements, that is alkali metals. So this is not a suitable answer, this is not a chalcogen. So suitable answer is D. The geometry of IF7 iodine heptafluoride molecule is octahedral, trigonal bipyramidal, tetrahedral, pentagonal bipyramidal. Octahedral for 6, trigonal bipyramidal for 5, tetrahedral for 4, heptagonal is pentagonal bipyramidal. So the suitable answer is D. Next, in XeF2, xenon difluoride, xenon tetrafluoride, xenon hexafluoride. The number of lone pairs of xenon are respectively xenon difluoride. This is its structure. Which has 3 lone pair of electrons. Xenon tetrafluoride. It has 2 lone pairs. Xenon hexafluoride. Which contains 1 lone pair of electrons. So, xenon difluoride contains 3 lone pair of electrons. Xenon tetrafluoride contains 2 lone pair of electrons. Xenon hexafluoride contains 1 lone pair of electrons. So, order is 3, 2, 1. So, suitable answer among the following is D. The number of d electrons present in an atom xenon. Xenon atomic number is 54. D electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p, 6, 5s2, 5p6. D electrons present in an atom of xenon. D electrons 3d10, 4d10. So, answer is B, that is 20. 20 d electrons are present in xenon. Next, the formation of oxygen hexafluoroplatinate. This is the first compound prepared by Niels Bartlett with xenon on the basis of the formation of xenon fluorides. This is because options: oxygen and xenon have same comparable sizes. It is true. Both oxygen and xenon are gases. Not so correct. Xenon and oxygen have comparatively same ionization energies. Oxygen ionization energy is 1180 kilojoules per mole. Ionization energy required to remove 1 electron from isolated gaseous atom. Xenon has 1170 kilojoules per mole. So, both the elements having same ionization energies as well as same comparable sizes, the suitable answer is D, both A and C. So, next question. The most abundant inert gas in air. ಗಾಳಿಯಲ್ಲಿ ಸಿಗೋ ಇನರ್ಟ್ ಗ್ಯಾಸು ಜಾಸ್ತಿ ಇರೋ ಇನರ್ಟ್ ಗ್ಯಾಸ್ ಯಾವುದು? ಹೀಲಿಯಂ, ನಿಯಾನ್, ಆರ್ಗಾನ್, ಕ್ರಿಪ್ಟಾನ್. ತಮಗೆಲ್ಲರಿಗೂ ಗೊತ್ತಿರೋ ಹಾಗೆ ಕ್ರಿಪ್ಟಾನ್ ಈಸ್ ದ ಮೋಸ್ಟ್ argon is the most abundant inert gas available in the air. So, suitable answer is C. Next, Noble gases are group of elements which exhibit high chemical activity, low chemical activity, minimum electronegativity, paramagnetic properties. Noble gases is nothing but inert gases. Their electronic configuration is completely filled. Hence, they do not show any interest with respect to the chemical activity. Minimum electronegativity. Noble gases have zero electronegativity. These elements do not contain unpaired electrons, hence it do not show paramagnetic behavior. So, ಈ ಎಲ್ಲದರಲ್ಲಿ suitable answer is inert gases do not show interest towards low chemical activity. So, answer is B. The lightest inflammable gas. ಈ ಏರ್ ಬೆಲೂನ್ಸ್ ಇದರಲ್ಲಿ nowadays they are filling with hydrogen because lightest and at the same time they are non-inflammable. They do not catch us fire due to inertness. Hydrogen is highly flammable even though it is lighter. Oxygen is a supporter of a combustion. Nitrogen is neither supporter of a combustion nor hence helium is filled in non-inflammable gas, hence it is filled in air balloons. Suitable answer is B. Next, helium is added to oxygen used by sea divers because it is practically not soluble in blood even at high pressure, lighter than nitrogen, readily miscible with oxygen, less poisonous than nitrogen. Helium gas oxygen ಜೊತೆ ಸೇರಿಸೋದ್ರಿಂದ when the person goes to the depth of the ocean due to high pressure, it do not soluble in blood even at high pressure. Earlier air was filled, it contains oxygen as well as nitrogen, but at high pressure nitrogen was dissolved in the oxygen. When a person comes out of the ocean, the nitrogen gas, the absorbed nitrogen gas has to comes out, which causes a severe pain called bends. To avoid that condition, nowadays helium is added to oxygen instead of nitrogen. The suitable answer is A. The two electrons in an helium atom belongs to different shells, belongs to different orbitals, have different spins, have different quantum numbers. Helium atomic number is 2. Its electronic configuration is 1s2. Same orbit. 1 indicates the same orbit. S indicates the same orbital. That is same azimuthal quantum number as well as magnetic quantum. When comes to the answer 2, both electrons which are having different spins. So, suitable answer is have different spins C. In solid argon, the atoms are held by van der Waals forces, ionic bonds, covalent bonds, hydrogen bonds. Solid argon dalli atoms are held by van der Waals forces. So, answer is A. The gases used for inflating aeroplane tires is aeroplane tires alli yava gas anna balastara. Hydrogen gas at high pressure and temperature, it may catch us a fire due to high combustible gas. argon inertness and heavier, whereas helium is lighter, non-inflammable, and at the same time it is filled at high temperature and pressure. It do not react with rubber, hence it is filled in inflating aeroplane tires. Answer is B. The shape of the xenon dioxide difluoride molecule is, options are square planar, trigonal bipyramidal, tetrahedral, seesaw. If you observe the xenon dioxide difluoride, the structure is this is the structure of xenon dioxide difluoride. It looks like seesaw structure or pyramidal structure. So, among the suitable answer is D, seesaw structure. Next question. Marshall's acid is H2SO5. The formula of Marshall acid is H2S2O8, H2S2O7, H2SO3. Marshall acid is called as peroxy disulfuric acid. Its formula, as we discussed already, H2S2O8. H2SO5 is called Carros acid. H2S2O7 is called oleum. H2SO3 is called sulfurous acid. So, peroxy disulfuric acid is called Marshall's acid. Its suitable answer is H2S2O8, B. Next, bond angle in H2O is 104 degrees 28 minutes or 5 degrees. Is higher than the bond angle of H2S, 92.1 degree. The difference is due to, when we discuss about the structure of water, in water, the high electronegative element oxygen is present, which has a hydrogen bonding takes place between hydrogen as well as oxygen, and it contains two lone pair of electrons. But in case of H2S, no hydrogen bonding takes place. It is less electronegativity. So, the difference is due to, when we observe the options, oxygen is diatomic, correct, and sulfur is tetraatomic, correct. Difference in electronegativity of sulfur and oxygen. Difference in oxidation state of sulfur and oxygen. Difference in shapes of hybrid orbitals of sulfur and oxygen. So, when we observe all the options, particularly the bond angle decreases due to electronegativity of sulfur and oxygen. So, suitable answer is B, difference in electronegativity of sulfur and oxygen. Carros acid is, it is called as persulfuric acid. Its formula H2SO5. H2S2O8 is called Marshall's acid. H2S2O7 is called oleum. H2SO3 is called sulfurous acid. Carros acid is sulfuric acid called, its formula is H2SO5. So, suitable answer is A. The correct order of acidic strength is, when we observe the following options, potassium oxide belongs to first group of elements, alkali metals. It is basic in nature. Calcium oxide, base. Magnesium oxide is also base. So all the three are bases. This is not comes under answer at all. Basic in nature. Next, carbon dioxide, nitric oxide, sulfurous acid. It is acidic in nature. Sodium oxide, magnesium oxide, aluminium oxide. These three are basic in nature. Sodium belongs to alkali metals, magnesium belongs to alkaline earth metals, aluminium also belongs to alkaline earth metals. So these are all basic in nature. Cl2O7, perchloric acid, sulfur dioxide, P2O4, phosphorus pentoxide. It is a dimer. Among these, HClO4, perchloric acid, next H2SO3, H3PO4, perchloric acid, sulfurous acid, orthophosphoric acid. Among these, perchloric acid is stronger than sulfurous acid, stronger than orthophosphoric acid. So the same acidic strength is resemblance to this one. So suitable answer is Cl2O7 greater than, that is nothing but perchloric acid, sulfurous acid and phosphoric acid. So the correct order is D. They are acidic in nature. Next question. Which of the following statement is regarding sulfur is incorrect? Sulfur molecule is paramagnetic. True. The vapors of at 200 degrees consists of mostly S8 rings. It is also correct. At about 725 degrees centigrade, the gas mainly consists of S2 molecules. Correct. The oxidation state of sulfur is never less than +4 in its compounds. Sulfur generally forms the compounds, or it has oxidation state +2, +4, +6, as we discussed in the synopsis. So the answer is, incorrect answer is, the oxidation state of sulfur is never less than +4 in its compound. It is a wrong answer. So answer is D. Incorrect statement. Next, which of the following is not correct? All the oxides of the halogens are powerful oxidants. All the oxides of halogens are powerful oxidants. Correct. The compounds of oxygen and fluorine are not called oxides but fluorides. For example, when a compound is OF2, oxygen difluoride, it is not called as oxide. It is called as a fluoride. Oxygen fluorides forms oxo acids. Oxygen fluorides form oxo acids. D option. In oxo halides, bonds are mainly covalent due to small difference in electronegativity of oxygen and halogen. Oxygen is electronegativity is correct comparatively halogens. So wrong answer is, among the following, oxygen fluorides forms oxo acids. It is not suitable. They form oxygen atoms. So suitable answer is C. Hydrogen bonding is the strongest in, as per family, oxygen family, sulfur family, fluorine, nitrogen. This is fifteenth, 17th group, 16th group, 14th group of the nitrogen. As you know, hydrogen bonding takes place with highly electronegative elements. Among these four elements, fluorine has highest electronegativity, than oxygen, than fluorine, nitrogen. Sulfur do not form electronegativity. So among the options, water, H2S, hydrogen fluoride and ammonia. So HF is highest in hydrogen bonding or strongest in hydrogen bonding. So answer is C. Next, the compounds used in refrigerants. As you know, generally refrigerator alli balaso compounds yavappa andre chlorofluorocarbons, that is CF2, Cl2. It is also called dichloro, difluoro, methane, carbon disulfide, tetrachloromethane, tetrafluoromethane. So among the four options, fluorochlorocarbons is A. The suitable answer is A, chlorofluorocarbons. Next, in which of the following pairs the first gas bleaches, the color of flower by reduction and second by oxidation? Sulfur dioxide bleaches the materials by reduction, that is by producing nascent hydrogen atoms. Reduction. Chlorine bleaches by oxidation. So among the following answers, sulfur dioxide bleaches the materials by reduction, chlorine bleaches the materials by oxidation, and sulfur dioxide bleaches the materials by reduction, which is a temporary bleaching agent. Chlorine bleaches the materials by oxidation, called permanent bleaching agent. Hence, the suitable answer among the following is A, SO2 and Cl2. Next, the bond Br and Cl is pure covalent, ionic, coordinate, polar covalent. When BrCl on dissociation by applying energy, Br acquires positive charge, chlorine acquires negative charge. This indicates that the bond between Br and Cl is polar covalent because polarity is developed between the two ions. So suitable answer is D, polar covalent. Next, fluorine does not show positive oxidation state due to its smaller atomic size, volatile nature, highest electronegativity, gaseous state. Among the periodic table of elements, fluorine readily accepts the electrons due to high electronegativity. So, it does not lose the electrons to attain positive oxidation state. It always accepts electron due to high electronegativity. So among the options, smaller atomic size, correct, volatile nature, highest electronegativity gaseous state. A, B, D or A, B, C, D. Even though it looks like correct, but appropriate answer is highest electronegativity of fluorine. It does not allow to exhibit positive oxidation state. So answer is C. Next, the number of p electrons in bromine atom is, bromine atomic number is 35. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. 10, 20, 30. P electrons. No problem. 2p6, 3p6, 4p5. So total p electrons in bromine is 6 plus 6, 12, 12 plus 5, 17. So answer is A. Next, hydrogen bonding does not influence the boiling point of. Hydrogen bonding is taken place between water, that is oxygen and hydrogen. HF, highly electronegative element, hence it also forms hydrogen bonding. Ammonia, nitrogen and hydrogen, there is hydrogen bonding. Hydrogen bonding takes place in case of H2O, Hi and NH3. It does not take place in case of Hi. So hydrogen bonding, no way it forms in the Hi, it does not influence the boiling point. So answer is B. Hydrogen bonding does not take place due to large atomic size of iodine. So answer is B. Next, which of the following is least polarizable? Xenon, neon, helium and krypton. Polarizability depends upon the size of the atom. As the larger size, the polarizability is maximum. So in case of helium, due to smaller in size, its polarizability is very less. So order of polarizability increases down the group. So helium has least polarizable. Hence the suitable answer is C. The oxidation state of xenon plus 6 in ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ದಲ್ಲಿ xenon plus 6 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ತೋರಿಸುತ್ತೆ? xenon oxy tetrafluoride XeOF4, xenon oxy difluoride xenon dioxy difluoride. ಈ ಮೂರು ಕಾಂಪೌಂಡ್ಸ್ ಅಲ್ಲಿ ಯಾವ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ xenon plus 6 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ತೋರಿಸುತ್ತೆ? ಫಸ್ಟ್ ಒನ್ -4 ಫ್ಲೋರಿನ್, ಆಕ್ಸಿಜನ್ -2, ಎರಡು ಸೇರಿಸಿದ್ರೆ xenonಗೆ +6. ಫ್ಲೋರಿನ್ -2, ಆಕ್ಸಿಜನ್ -2, xenonಗೆ +4. -2 ಫ್ಲೋರಿನ್, ಆಕ್ಸಿಜನ್ -2 into 2 -4, xenon +6. ಸೊ ಯಾವ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ xenon +6 ತೋರಿಸುತ್ತೆ ಅಂದ್ರೆ xenon oxy tetrafluoride and xenon dioxy difluoride. So answer is, among the suitable answer is D. Both A and C. Next, the monoatomic gas. Monoatomic. Now, ಮಾಮೂಲಾಗಿ ಆಕ್ಸಿಜನ್ ಬರೀದ್ರೆ O2, ಓಜೋನ್, O3, ಫ್ಲೋರಿನ್, F2 ಅಂತ ಬರಿತೀವಿ. ನಿಯಾನ್ ಬರೆಯೋದಾದ್ರೆ Ne ಅಂತ ಬರಿತೀವಿ. ಈ ರೀತಿಯಲ್ಲಿ ಬರೆಯೋದನ್ನ ಮಾಲಿಕ್ಯುಲಾರ್ ಸ್ಟೇಟ್ ಅಂತ ಕರಿತೀವಿ. ನಿಯಾನ್ ಅನ್ನ ಮಾತ್ರ ಮೋನೋ ಅಟಾಮಿಕ್ ಸ್ಟೇಟ್. ಈ ಹೀಲಿಯಂ, ನಿಯಾನ್, ಆರ್ಗಾನ್, ಕ್ರಿಪ್ಟಾನ್, ಝಿನಾನ್, ಈ ಇನರ್ಟ್ ಗ್ಯಾಸಸ್ ಎಲ್ಲವೂ ಮೋನೋ ಅಟಾಮಿಕ್ ಸ್ಟೇಟ್ ಇರೋದ್ರಿಂದ ದ ಸೂಟಬಲ್ ಆನ್ಸರ್ ಈಸ್ ನಿಯಾನ್. ಆನ್ಸರ್ ಎ. The gas which filled in electrical bulbs is argon, nitrogen, helium, carbon dioxide. ಈ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಬಲ್ಬ್ಸ್ ಅಲ್ಲಿ ತುಂಬೋ ಗ್ಯಾಸ್ ಯಾವುದು? ಆರ್ಗಾನ್, which produces orange color when electricity is passed into it. So, argon will be filled in the electrical bulbs. So, answer is A. Next, radon is obtained from radium with atomic number 86 and atomic mass is 226 by alpha decay, beta decay, gamma decay, N decay. As you know, radioactive disintegration is a property of an element. When element is exposed to the air, it exhibits the or it decays the alpha particles as well as beta particles and gamma particles. Alpha particles is nothing but helium atoms. Beta particles is nothing but electrons. Gamma, they do not have any charge. When radium (86-226) emits radon with 84 and 222. The left out is, on subtraction, 226 minus 222, nothing but 4. 86 minus 84 is 2, which is nothing but helium molecule. This is, as usual, can be considered as alpha particle. So, alpha decay is possible. The suitable answer is A. This radioactivity property, the special type of property, as you studied, the radioactive elements are discovered by Madame Curie. She got Nobel Prize for this achievement. So, suitable answer is A, alpha decay, which is resemblance of the helium atom. It possesses mass is 4, charge is 2. Next, among the inert gases, the maximum number of compounds are possible with. ಯಾವ ಎಲಿಮೆಂಟ್ ಅಲ್ಲಿದ್ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ನಂಬರ್ ಆಫ್ ಕಾಂಪೌಂಡ್ಸ್ ತಯಾರು ಮಾಡಬಹುದು? Xenon, neon, argon, krypton. Till olden days, inert gases, they do not undergo any reaction. But Niels Bartlett, the person, he is the first compound was prepared by the Niels Bartlett called Xenon Hexafluoroplatinate. This is the first compound prepared by Niels Bartlett, because the reason is xenon is larger in size and which reacts with oxygen and fluorine will form many varieties of compounds: xenon difluoride, xenon dioxydifluoride, xenon tetrafluoride, etc. Niels Bartlett is the person when he observed with oxygen having ionization energy 1170 kilojoules per mole. To remove one electron from oxygen atom, it needs 1180 kilojoules. But whereas xenon needs 1170 kilojoules. By observing these two values, from xenon also varieties of the compounds can be prepared. Hence, he prepared the first compound, xenon hexafluoroplatinate, which has an orange colored. So, from that day onwards, varieties of the compounds, maximum number of compounds are prepared by using xenon. So, the suitable answer is xenon. Answer A. Next, the hydrogen bond is the strongest in. As you studied, there is ionic bond, covalent bond, coordinate bond, metallic bond, hydrogen bond. Ionic bond formed between two atoms by losing and gaining electrons. One atom loses electron, one atom gains electrons. When dissolved in the water, it produces the positive ions as well as negative ions. Covalent compounds. This bond is formed by sharing of electrons. Both the atoms shares the electrons. For example, hydrogen, hydrogen. Both the atoms shares one electron each and covalent bond is formed. Coordinate bond. One atom donates electrons to other which do not have electrons and which is denoted by the allo mark that we are observed in the coordination compounds. For example, cobalt, hexammonium chloride. In this compound, cobalt accepts electron from ammonia. Ammonia is a ligand which donates the electrons to cobalt. Coordinate bond means only one atom or a molecule donates electron, other will accept it. In case of hydrogen bond, hydrogen bond is an attractive force between highly electronegative element and hydrogen atom. Hydrogen bond is always formed between highly electronegative element and hydrogen bond, hydrogen atom. In chemistry, generally, hydrogen bond takes place between fluorine, oxygen, nitrogen only with hydrogen. In these three also, fluorine is highly electronegative. Hence, the strongest bond is formed between hydrogen and fluorine. Hydrogen, fluorine, hydrogen. Among the electronegativity properties, fluorine has highest electronegativity than nitrogen and oxygen. Hence, the strongest bond is fluorine, hydrogen, fluorine. Fluorine, hydrogen, oxygen. Fluorine, hydrogen, nitrogen. Unpredictable. So, among the suitable one, the answer A is correct. Fluorine, hydrogen, fluorine. Next question. The correct order of thermal stability of halogen acids. Thermal stability, they are stable at high temperatures. Among the halogen acids, HI, HBr, HCl, HF. In between HF, HCl, HBr, HI. The strong bond is formed between HF. Reason is fluorine is highly electronegativity. Electronegativity property decreases down the group. So, in between hydrogen and fluorine is a very strong bond than HCl, than HBr, HI. Thermal stability, even at high temperature, the bond cannot break. So, order, first one, HI, weak bond. So, the option A is wrong. HCl, comparatively HF and HCl, in case of HCl is also weak. So, that answer is also not suitable. Third one, HF correct, HCl is correct, HBr is correct, HI is correct, order is correct. Then when comes to the D option, HF is correct, HCl is correct, HI is not correct, it should be HBr. So, among the four options, C option is correct. HF greater than HCl, greater than HBr, greater than HI. So, answer C is correct. Next, the correct order. Next question. The most efficient agent for the absorption of sulfur trioxide is, as we discussed in the manufacturing of sulfuric acid by contact process, sulfur trioxide is absorbed in sulfuric acid to get oleum. Many students may have doubt. If we add water ಹಾಕಿದ್ರೇನೆ ಬಂದುಬಿಡುತ್ತೆ sulfuric acid, sulfur trioxide here. This itself will get the sulfuric acid. But this reaction not to be done. Reason is, this reaction is highly exothermic and it is not under our control to get sulfuric acid. Hence, it is passed through the sulfuric acid 98%. Then it forms oleum H2S2O7. It is called, it is oil-like liquid called oleum. This is further treated with required quantities of water to get sulfuric acid. This is sulfur trioxide passed into the 98% of sulfuric acid, which is in the absorption tower of the contact process to get oleum. Oleum is H2S2O7. This is further treated with required quantities of water to get sulfuric acid. So, among the answers, 80% of sulfuric acid, 98% of sulfuric acid, 50% of sulfuric acid and 20% of sulfuric acid. The suitable answer is 98% of sulfuric acid. Next question. Noble gases are used in discharge tubes. Means when light falls on it, it will produce the colors. To give different colors. Reddish orange glow is due to. Noble gases have a penetrating power. Hence they are used in beacon lights. That is where in airport the airport they are using these lights for those lights are called beacon lights. While landing, the pilot should observe the runway. So to get orange color, and at the same time all signboards on the national highways will be painted with noble gas compounds. So among the following, reddish orange glow is due to neon, ಈ ಪಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ CET ಕೋಚಿಂಗ್ಗೆ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆಲ್ಲ ಚೆನ್ನಾಗಿ ತಿಳ್ಕೊಂಡಿರುತ್ತೆ ಅಂತ ಹೇಳ್ತೀನಿ. ತುಂಬ ಧನ್ಯವಾದಗಳು. ಈ ಒಂದೂವರೆ ಸಮಯ ತಮಗೆ ಈ ಚಾಪ್ಟರ್ಗಳಿಂದ 2-3 ಕ್ವಶನ್ಸ್ವರೆಗೆ ಬರಬಹುದು. ಚೆನ್ನಾಗಿ ಇದರ ಮೇಲೆ ಸ್ವಲ್ಪ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಮಾಡಿ ಓದಿದರೆ ನಾವು ಮುಂದೆ ಬರುವ CET ನೀಟ್ ಎಕ್ಸಾಮ್ಗೆ ತಮಗೆಲ್ಲ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಈ ಅವಕಾಶವನ್ನು ಕೊಟ್ಟ ಪದವಿ ಪೂರ್ವ ಶಿಕ್ಷಣ ಇಲಾಖೆಗೂ ಇಂಥ ಕಾರ್ಯಕ್ರಮಗಳು ನಡೆಸ್ತಾ ಇರೋ ನಮ್ಮ ಇಲಾಖೆ ಸರ್ಕಾರಕ್ಕೂ ತುಂಬ ಧನ್ಯವಾದಗಳು ಹೇಳ್ತಾ ನನ್ನ ಈ ಕ್ಲಾಸನ್ನು ಮುಗಿಸ್ತಾ ಇದ್ದೀನಿ. ತುಂಬ ಧನ್ಯವಾದಗಳು. ಥ್ಯಾಂಕ್ ಯು.